Now that we've discussed reflections of functions, we're going to talk about specific types of functions whose reflections have particular properties. So we'll call a function even, so f of x is even if it is symmetric about the y-axis. And specifically, what I mean by symmetric is when you reflect f of x, you get the same graph. So on reflecting f of x about the y-axis, you get the same graph. A classic example of an even function is the function x squared. So if I go ahead and plot this toolkit function, draw in some axes, and I think I'll just barely have enough room here to get a good plot. Then go ahead and connect here. So this is a quick sketch of the function x squared. What happens when you reflect it about the y-axis? Well, if you take the point 2, 4, that should be 2, 4. It looks like it's 2, 3. So let's go ahead and fix that. 2, 4 is all the way up here. There we go. So if you take that point 2, 4 and you reflect it about the y-axis, remember that means you take the x value and you multiply it by -1, you get over here on the left side at -2, 4. If you take 1, 1 and reflect it about the y-axis, you get -1, 1. 0, 0 stays exactly where it is. And then if you reflect -1, 1, you get 1, 1, and etc. And what you have is the exact same graph as before. Okay, so a function is even if it is symmetric about the y-axis. That is, if you reflect it about the y-axis, you get the same graph. We'll say a function is odd, f of x is odd, if it is symmetric about the origin. If it is symmetric about the origin, which it's not so clear what symmetric about the origin means. Perhaps it was clear what symmetric about the y-axis means, but perhaps this is a little bit more convoluted. What symmetric about the origin means is on reflecting f of x about the x, then y-axis, then y, I suppose, axes, you obtain the same graph. The classic example of an odd function is x cubed. So I'll go ahead and draw in a sketch of x cubed. Get some axes in here. So 0, 0 is on the graph, 1, 1, -1, -1 is on the graph. And at 2, the y value is 8, which is really tall. But so I'm not going to fill in that y value. Instead, I'll just draw the shape of the graph. And now let's go ahead and, if this is f of x, let's go ahead and reflect this twice and see what happens. So if you take 0, 0 and reflect it twice, then, well, it stays in the same spot. At 1, 1, we reflect the first time about the, let's do the x-axis. It doesn't matter if you do the x-axis first or the y-axis first. So if I reflect about the x-axis, multiply y by -1, then I get there. And then if I now multiply the x value by -1, I get to -1, -1. And finally, if I take this third point, -1, -1, on the graph of f of x, if I reflect first about the y-axis, I get here, and if I reflect now about the x-axis, I get here. So you can see I only did 3 points, but I think that's sufficient to explain that this graph here, f of x, if you reflect it twice, the graph you obtain as a result is the same. And that's what we mean by symmetric about the origin. You reflect about the x and the y-axis, you obtain the same graph. Now, there is an unfortunate common misunderstanding that results from calling these types of functions odd and even. So the unfortunate misunderstanding is sometimes students think that a function must be even or odd, and that results from the fact that a number is either even or odd. With functions, a function could be neither even nor odd. So if a function doesn't have these symmetries that we're talking about, it's not symmetric about the y-axis or the x-axis, then it's neither even nor odd. And there are plenty of functions that are neither even nor odd.